Module 10, Section 8.5, Random Variable, Probability Distribution and Expected Value. Objectives. Objective 1. Understand what is meant by a random variable and a probability distribution. Objective 2. Compute the expected value of a random variable. And Objective 3. Use the expected value of a random variable in decision making. Random variables. Suppose we flip a coin 2 times. The possible outcomes are head head, head tail, tail head, tail tail. Rather than being interested in the outcomes, we might be interested in the number of heads. When experiments are conducted in a way such that the outcome is a numerical result, we say the outcome is a random variable. In our example, if the random variable x represents the number of heads in 2 flips of a coin, the possible values of x are 0, 1 and 2. A random variable is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. Random variables are denoted by letters such as x. There are 2 types of random variables. One is called discrete random variable and the other one is called a continuous random variable. A discrete random variable has either a finite or countable number of values. A continuous random variable has infinitely many values. Discrete probability distribution. A probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be given in the form of a table, as a graph, or using a mathematical formula. Here is a typical example. Suppose we flip a coin 2 times. We have the 4 possible outcomes here, and we are going to define the random variable x as the number of heads in 2 flips of a coin. And we can find out that the possible values of x are 0, 1 or 2. So when there are 2 heads, we will get the count of heads as 2. When it is tail followed by tail, the number of heads will be 0. If it is head followed by tail, the count of head is 1. Tail followed by head, the count of head is again 1. We are going to convert this into a probability distribution. We write the values of x, which are 0, 1 and 2, and calculate the corresponding probabilities. The value x equal to 2 has got a probability 1 out of 4 because there is only one outcome corresponding to x equal to 2. Similarly, the value x equal to 0 has got a probability 1 out of 4. 1 out of 4 possibilities. But x equal to 1 happens 2 times, either through ht or through th. So we have 2 out of 4 possibility, giving the corresponding probability as 1 by 2. So this will be a discrete probability distribution. Properties of probability distribution. The first property states that the probability distribution of a random variable x is a function which only takes on values between 0 and 1. So the probability of any value of x will be lying between 0 and 1, inclusive. Second property says that the sum of all the individual probabilities must always equal 1. So if you add all the probabilities in a probability distribution table, it should be equal to 1. Here is an example. We have the random variable x defined as the number of customers in line waiting for a bank teller. And the first column gives the possible values of the random variable 0, 1, 2, 3, 4, 5. And the second column gives the corresponding probabilities. Notice that these probability values are all lying between 0 and 1, and the total probability is coming out to be 1. So if you add this column, you will get the total to be 1, which is property number 2. Here is another example. Determine the required value of the missing probability to make the distribution a discrete probability distribution. So this is a discrete probability distribution. So this probability corresponding to x equal to 4 is unknown. Let's call that to be something like A. So property 2 tells that the sum of the probability has to be 1. So if you add these columns, we will get A plus 0.26 plus 0.38 plus 0.14, which will be 0.78. This total probability has to be equal to 1. So if we solve for A, we will get 1 minus 0.78, which will be equal to 0.22. So the probability of x equal to 4 is equal to 0.22. Objective 2, expected value of a random variable. Suppose we are given a discrete probability distribution like this, with x taking values x1, x2 and so on up to xn, and the corresponding probability is given as p1, p2 all the way up to p sub n. The expected value is calculated by multiplying the random variable values with the corresponding probability and adding them together, which is this expression x1 multiplied with p1 plus x2 multiplied with p2, and keep on doing like that all the way up to xn multiplied with pn. If you add them all, we will get the expected value of the random variable, and this will be denoted using this notation. Expected value of a random variable x is given as sigma x multiplied with px. Here x is the value of the random variable, px is the corresponding probability. How is this interpreted? If you perform an experiment thousands of times, record the values of the random variable every time and average the values, you should get a number close to the expectation of x. Computing the expected value, there are two steps. Form the probability distribution of the random variable, then multiply each value of the random variable x by its corresponding probability, and if you add them all, we will get the expected value of the random variable x. Let's do an example. If the probability distribution for the random variable x is given in the table below, what is the expected value of x? So we have this discrete probability distribution. The first row is the set of random variable values. Second row is the corresponding probability. So in order to find the expectation of x, we need to use this formula. Expectation of x will be equal to sigma xi multiplied with probabilities pi. So this will come out to be negative 6 multiplied with the corresponding probability 0.5 plus 4 multiplied with the corresponding probability 0.3, 3 multiplied with the probability of x equal to 3, which is 0.2. If you add them together, we will get negative 1.2, which is the expected value of the random variable x. Application problems. A rock concert producer has scheduled an outdoor concert for March 8. If it does not rain, the producer stands to make a 20,000 profit from the concert. If it does rain, the producer will be forced to cancel the concert and will lose $12,000. The producer has learned from the National Weather Service that the probability of rain on March 8 is 0.4. Based on this information, write a probability distribution that represents the producer's profit. Find and interpret the producer's expected profit. Here is a solution. We can create a probability distribution. If we assume that x represents the amount of money the producer will make, which is a random variable, we have two possible values of x. If it rains, the producer will lose $12,000, so the x value will be negative 12,000. So that is this value up here with a corresponding probability of 0.4. In the other case, if it does not rain, the producer will make a profit of $20,000. So the value of x will be 20,000 with a probability corresponding to no rain, which is 0.6. So if the probability of rain is 0.4, probability of not rain will be the complement, which is 1 minus 0.4 equal to 0.6. To calculate the expected value, we multiply the probabilities and the value of the random variables, add them together. So we will get the column sum here as sigma x multiplied with px, that will be 7,200. The expected value is interpreted as a long-term average. The number 7,200 means that if the producer arranged this concert many times in identical circumstances, he would be ahead by $7,200 per concert on the average. It does not mean he will make exactly $7,200 on March 8. He will either lose $12,000 or gain $20,000 on that day. But in the long run, he can expect to make $7,200 per concert. Here is another example. A card is drawn from a 52 card deck. If the card is a king, you will win $35. Otherwise, you will lose $6. What is the expected value of the game? So we need to define the random variable x as value of the game. And then construct a probability distribution for x. So x values and the probability corresponding to that. If the card drawn is a king, x value will be 35. So 35 will be the x value with a probability. The probability of drawing a king out of 52 deck card will be 4 kings out of 52, which will be 4 by 52. That will come out to be 1 over 13. So this probability will be 1 by 13. If the card drawn is not a king, we will lose $6. So that means the value of x will be -6 with a probability. So if you take your 4 kings, there will be 48 cards left. 48 out of 52 will be the probability. That will come out to be 12 divided by 13. So this value will be 12 divided by 13. So that is the table describing the probability distribution. To get the expected value, we need to multiply the probabilities with the x values and add them together, which is like 35 multiplied with 1 by 13 plus -6 multiplied with 12 by 13. When we calculate this, we will get -1.06. Okay, one more example. The annual premium for a $25,000 insurance policy against the theft of a painting is $100. If the probability that the painting will be stolen during the year is 0.025, what is your expected return from the insurance company if you take out this insurance? So we can construct the probability distribution here. If x is equal to the return from the insurance company, the possible values of x will be, we have two cases here. One case where the painting is stolen, so the probability for that will be 0.025, in which case we will be getting $25,000 from the insurance company, but we have to pay $100 for the premium. So the return from the insurance company will be 25,000 minus the premium amount, which is 100. We will get $24,900. So the x value will be 24,900. In the other case, we will only be paying the $100 premium to the insurance company, but we will not be getting any money from the insurance company. So because we are paying that amount, it will be -$100, and the probability for that case will be 1 minus 0.025. So we will get 0.975. So this will be probability 0.975. So this table is the probability distribution for this case. We have two values for x and the corresponding probabilities. So to get the expected value, as we did before, we need to multiply the x values with the probability and add them together. So that will be 24,900 multiplied with 0.025 plus -100 times 0.975, and we are going to get a value $525. That will be the expected return from the insurance company.